Welcome to the learning module for Pedigree Analysis. This is Dr. Tefke for the Cellular and Molecular Medicines course. After completing this learning module, students should be able to interpret the mode of inheritance from a family pedigree. A pedigree is a diagram of family relationships that uses symbols to represent people and lines to represent genetic relationships. Squares represent males, circles represent females. Closed symbols represent affected individuals. Horizontal lines extending from males and females represent matings. Vertical lines descending from a couple represent their children. Pedigree analysis is an important tool for studying inherited diseases. Pedigree analysis uses family trees and information about affected individuals to figure out the genetic basis of the disease from its inheritance pattern, and to predict the risk of disease in future offspring in a family. In autosomal recessive inheritance patterns, the trait will be rare in the pedigree and often skip generations because it can remain hidden in heterozygous carriers. Since it is autosomal, it will affect males and females equally. In autosomal dominant inheritance, the trait will be common in the pedigree and found in every generation. Affected individuals will transmit the trait to approximately half of their offspring, regardless of sex. With X-linked recessive inheritance, the trait is rare in the pedigree and often skips generations. Importantly, affected fathers cannot pass the trait to their sons, and males are more often affected than females. An X-linked dominant trait will be common in the family pedigree. Affected fathers pass on the trait to all their daughters, and males and females are equally affected. Inheritance of Y-linked disorders only go from affected father to all their sons, not to any of the daughters. Pedigree analysis for mitochondrially inherited disorders will show that the inheritance only comes from affected mothers. Affected males do not pass on the disorder. Here's a quick method that I utilize to determine the mode of inheritance from pedigrees. The first step is to determine if it's dominant or recessive. This can be done by asking the simple question, do two unaffected parents have an affected child? If the answer to this question is yes, it is a recessive inheritance pattern. If all affected individuals have an affected parent, it is a dominant inheritance pattern. The next step is to determine whether it's autosomal or sex-linked inheritance. Are both sexes affected equally? If so, it's likely to be autosomal. If not, it may be sex-linked. If it is sex-linked, are any females affected? If so, it may be X-linked. X-linked dominant traits are more frequent in females than males, while X-linked recessive traits are more frequent in males than females. If no females are affected, it's likely Y-linked. The last step is to check your deduction by filling in the genotypes in the family tree. Now, let's work a few examples. So let's analyze this pedigree for its mode of inheritance. So we begin by looking for unaffected parents with an affected child. And we find these parents with an affected child here. And another affected individual with unaffected parents here. So this is a recessive inheritance pattern. Now we just need to determine if it's autosomal recessive or X-linked recessive. To do this, we ask, are females and males affected equally? Here we see we have 7 females and 7 males with the condition, so it's likely to be autosomal recessive. We could also verify that it's not X-linked recessive by finding an affected female and looking at her sons or her father. If it were X-linked recessive, she would have to donate it to all her sons and have gotten it from her father. None of the affected females satisfy these conditions, so this is likely autosomal recessive. We can also rule out Y-linked because females have it, and rule out mitochondrial mode of inheritance because an affected female did not pass it on to all her children. All right, let's do another one. Dominant or recessive. Look at the parents of affected children. Do any unaffected parents have an affected child? Here we see we have an affected child from two unaffected parents. So this is either autosomal recessive or X-linked recessive. Since females are affected, we know it's not Y-linked. And we can find at least one affected female with some unaffected children, suggesting or confirming that it's not mitochondrial. Are both sexes affected equally? So we have 3 female and 5 males affected. So no, they're not affected equally. So this could be X-linked recessive. We verify X-linked recessive by checking the affected females. If it's X-linked recessive, all their sons should be affected and their fathers should be affected. Here we see an affected female with affected sons. So it could be X-linked. However, we don't know what her father's phenotype was. To complete the verification, here's another affected female with affected sons. But again, we don't know the phenotype of the father. So this is likely X-linked recessive, but it could also be autosomal recessive. We would need to know the phenotype of the affected female's fathers in order to conclude it was X-linked recessive. Here's another one. Does any affected child have unaffected parents? No. So this is a dominant inheritance pattern. We can rule out Y-linked because there are affected females. We can also rule out mitochondrial inheritance because an affected female has unaffected offspring. So are males and females equally affected? We have 7 females and 4 males, so this suggests that it's sex-linked. X-linked dominant seems likely because X-linked dominant has more females affected than males. We can verify the X-linked dominance by looking at the affected males. All the affected males should have an affected mother and affected daughters. If not, then it's autosomal dominant. Here we see an affected male with an affected mother and affected daughter. And here we see another affected male with an affected mother and affected daughters. This supports X-linked dominant inheritance. However, this affected male has an unaffected daughter, so this must be autosomal dominant. Okay, now it's your turn to try some.